Hi everyone.
Hi, Sandeep.
Hi, Sandeep.
Hey, Sandeep.
How are you doing?
Good.
Doing good. How are you?
I'm doing good. What? 4, 3, 6, 3, 8, 2. What? Join a meeting. For some reason. 4, 3, 6, 3, 8, 2.
What is this, Sandeep?
I'm trying to connect my iPad.
Oh, okay.
Progress.
All right. Now this is better. Okay. I'm hoping that, yeah. Perfect. Hi everyone. Hey Rahul. All right. Shall we start? Okay. Yes. Just keep. Okay. So let's start. And yes. Great. So where were we? We were, let me share my screen and let's get started. We are already 6 minutes late. Okay. All right. So this is the one that we talked about last time. And it's not.
Oh, yeah.
Oh, yeah. All right. So yeah, this is where we ended our discussion. And the discussion was around how would you solve the consecutive equations? Okay, so you are given these equations. So these equations, and you have to solve them using the code. Yeah. I'll turn off my camera today. And yeah. All right. Did anybody try this? No. Anyone? I know a couple of you have tried. And yes, I have not been able to pay attention much. I know Neil had tried. I have not looked at your solution. Do you want to share your screen, Neil? We can walk through it now.
Sure. It's very messy, but I shall show you what I have. Anyways.
Yeah. I think the first code has to be messy. Okay. If I see somebody's clean code and it's nice and it's working, I can guarantee that he has already solved the problem or he has copied it from ChatGPT. Okay. All right. Okay. Anybody tried solving the equations? No.
So, sorry, when you say solving the equations, are you talking manually or programmatically?
First you will do manually, then programmatically. Yeah.
Manually, yeah. I mean, I looked at the recordings today, so I was able to solve it
Okay.
manually, but
I too tried, Sandeep, actually, using both the techniques, the Gaussian elimination also I was trying to solve.
Amazing.
Sandeep, manually I try that. I how to solve the Gaussian algorithm. I revised the whole concept.
Okay. Okay.
Code, I think I need to write again.
All right.
Yeah.
All right. I can
So
tell you.
can you
Yeah.
guys see my screen?
Yeah, Neil.
Perfect. Okay. How do I explain this? The easiest way for people who know what Gaussian elimination to explain is, let's say if it's 3 variables equation, the most left side variable will always have 2 zeros. The second variable will have 1 zero, and the other 2 variables will have no zeros. So irrespective of, let's say, whatever equation you put, it's always going to be the case that like left is going to, like how it's done according to the YouTube videos is, left has like 2 zeros if it's a three variable equation. The center has 1 and the third has 0. Now let's say if it's a 4 variable equation, you just add plus ones to everything. So the first one will have 3, second one will have 2, third one will have 1, and the last one has 0, and then the other constant is also 0. So that's what I tried. That's the programmatic way which I tried to make this code. It is beautiful, as you can see. There's a lot of print statements along just because I was trying to figure out things. So the way how I did it is basically my main aim was using, let's say, the top equation. First, I'll solve the left side completely, make all zeros except the top equation. Then it goes to the next variable. And at the same time, what happens before, when I use the first variable to solve it, now it uses the second variable to solve it. Because if you use the first variable, then like the zeros in the first side will get completely messed up. And as you go along, it just does it more. So like, let's say for the third one, it goes down an equation and it just solves for the bottom remaining ones. So that's like, it's like a way where you could say it's kind of like a V. So like as it solves along one by one, the equations also keeps on going up, down and down and down as well.
Right.
So
Right.
that's the way how I did it. Now, when you look at the code, I had tried various things to make it work, and thankfully, the way I landed it is a very messy way, but it works at least in my case. So that's the main part for me, at least. So I think one of the biggest challenges which I faced was how to remove, let's say, how to make these variables to 0. And the main indicator which I used for that is LCM, but not like the typical LCM way. What I just did pretty much, and that's over here, is multiply, let's say, both of the variables, and then just found the common factor and just divided it to make it to 0. So I think that's the best way I can explain the Gaussian elimination. But if you guys want to see how it's done, I can definitely give it a shot. So let's say for right now, it's just for 2 variables. If I click play, oops. I should put
Yeah.
it here first. It comes up with the answer. It comes up with the zeros as well. And this is for 2 variables. Now, if you make it for 3, pretty much the same result. As I mentioned, like first variables will be 0. So yeah, top side will be 0. Then it goes again a bit lesser, and then it gets lesser from there. And finally, for 4 variables, it's the same result. So top 3 becomes 3 zeros, and then it becomes 2, and then it becomes 1, and this one will have all the variables. And
Yeah.
that's always the top. It's the top which always has everything filled.
Wonderful.
So
Wonderful.
that's the way I did it, and that's how I solved it.
Very impressive. Very impressive. Yeah, amazing. Anybody else wants to show? Wonderful, wonderful, very impressive. And yeah, so do you feel confident now?
So I got this right, but then you also gave me the sorting algorithms, right? Which is like I kind of got that right, but not exactly, because the recursion side I completely blew it. So yes and no is the right answer for that.
Okay, perfect. Never mind. So I think sorting algorithms are difficult to get, and it would take some time. But most important part is do not stop trying. Okay, because so I'll tell you, so in college I was trying to implement this notice board, and I did not know how to do SQL. So I ended up writing my own methods for deleting a record, adding a record in a file. Okay. And when I came to the DE show, they were teaching SQL, and I slept through the entire class because everything was very obvious to me. Okay. So so the thing is that if you struggle now, the rest of the computer science becomes so easy for you, and all the algorithms would become easy for you. If you do not struggle now, everything else will be Mandarin, and you will have to you'll try to memorize those things. Okay. Now, if you struggle now, rest of the things you won't have to memorize. Okay. And yes, and I feel myself very successful because you have been able to do it. Yes, I'm like super proud. All right. Yes, someone else wants to show. Yes.
By the way,
Amazing.
I still don't know how people solve this in 1 hour. It took me like a day to try to figure this out.
Next time now, if you do it again, you will just solve it. Okay. And yeah, first time I think it took me a couple of days in long back, but during interview it was I was able to do it like in 40 minutes or so. Okay. So first time is harder. And you know, your time to solve problems keep on decreasing logarithmically. So if you are solving something in let's say 10 hours first time, next time it becomes like 1 hour, and next time it becomes shorter. So and the same is true for all other, like the whole class of problems. And so the more problems you solve, the problem domain also expand exponentially. The most important part is if you are solving the problem, if you are memorizing the solutions, you won't be able to solve even the same problem. Okay, so that's a very important thing. I think Subodh can connect with this thing. Like in data structure algorithm, this is like a common pattern if you don't solve things by yourself. Yeah. Deepak, for what you answered, no, not me.
No, you asked, if you solved it or not. So I said no, I
Okay.
haven't solved it.
Okay. All right. All right. Wonderful. So there are quite a few things pending to do. One of the things that is pending to do is solving the consecutive equations. That is first thing. Second thing to solve is to do thing called I mean we have to do the we have to do the sorting algorithms, and then we will also do a bit of more maths. The thing is, many of the people who are coming from industry, they might wonder like, what's the point of any of this, right? Because they never saw the maths and the coding and the algorithms together at the same place in the job. That might make them like they might believe that none of these things are needed, but in reality, almost everything is needed. Okay, it's very, very important. And since I'm interviewing these days, I'm hiring multiple, like taking multiple interviews. I'm so surprised that even very senior people with data science background are not able to calculate the distance between 2 points. Okay. And yeah, it's very surprising to me, like by like giving three coordinates X, Y, Z, X1, Y1, Z1, X2, Y2, Z2, find the distance between that is very like maximum people are not able to do it. And it's so weird to me. Okay. I don't know how do people get a job here, honestly. And like people have like 10 years of experience into like machine learning and they have some PhD and not able to solve a basic distance between 2 points. I Subodh can tell me how it happened. Okay. It's like very strange to me. Like it feels like to me, it feels so awkward that am I asking the right question? Like somebody has a PhD on their resume and they have done LLM and RAG and they have done all sorts of things. They have built models and everything. But when I'm asking that using pen and paper, can you find the distance between 2 points? They're not able to do. Okay. And yes, it's very, very weird to me. Very weird. Okay. So nevertheless, but okay. So anybody want to show the Gaussian elimination a neater version? Somebody copied from ChatGPT.
Hi Sandeep, I tried Gaussian one. The
Okay.
complexity is very high, like it's n square.
And it'll be n cube. It'll be n cube.
Yeah, n cube, sorry, n cube.
The best algorithm had n to the power 2.7. That was the best algorithm for Gaussian elimination, but it's impractical. So the normal version is n cube. It'll be n cube. You
Yeah,
can't
yeah,
reduce
n
it.
cube, it's n cube.
Yeah. So it'll be n cube only.
But it
Cool.
is actually, yeah, it is actually for three equations only. I didn't
Nice.
try actually for two one.
Wait. So it's for 3 equation or any number of equations?
Just now I tried for three only. I need to try for multiple also.
I see.
Because
I see.
yesterday only I tried it, so I didn't
Okay.
try much. Yeah.
All right. Good. And okay. Are you guys inspired to try it out, everyone? Okay.
So should I stop or just
It's okay.
go
I
through?
think this is good. This is good. Yeah. Anybody tried the recursion way of doing it? No? No? Recursion way is way more easier than you think. See, the way it works is I'll walk you through it. Okay, let me start. So solving n equations, right, is easy. Okay, let's say you have these three equations, right? It has x plus 2y plus z equals 4. 2x plus 3y plus z equals 8. 5x plus 7y plus z equals 19, right? Now, what we got to do is we convert these equations to one less number of variables. If let's say you have 2x plus y equals 10 and x minus y equals 20, right? If you can just eliminate one variable at a time, right? You can eliminate one variable. Can you eliminate x from it? So you multiply the second equation with 2, okay? So that becomes 2x minus 2y equals 40. And first equation is 2x plus y equals 10. And I can subtract this equation, right? All right. No. Yes, this makes sense, right? So this turns out to be 2x minus 2y equals 40 minus 2x plus y. So you can see right-hand side subtracted from the right-hand side and left-hand side subtracted. So this turns out to be how much? So minus 2y minus 2y, that is minus 4y equals 30. So y is equal to
minus 3y. Minus 3y.
Thank you. You guys are awake. All right. Thank you. All right. Okay. So yeah. So y is 5. Right? And x is, and then once we
No,
calculate,
y is 10.
so what happened?
Y is 10. Minus 10.
And
Y should be minus 10.
Y minus 10.
now it's okay, right? So what I did was I had two equations.
Yes, Sandeep, we lost you.
Sandeep can't hear you now.
Hello? Hello?
Yep. Yeah, we can hear
Hey,
you.
We can
you're
hear you
back.
now.
Okay, thank you. All right. So yes. So what we did was we took three variable equation, okay? Two variable equations in x and y. We converted into y, and that's it. And then once we have one variable equation, we know how to solve it, correct? We know how to solve it. So in the same way, we'll take three variable equation, okay? Three variable equations. We will convert that to two variables. Then we'll convert it to one variable, and that's it. Is this clear? No. And we use the same technique. So what we did was we multiplied next value by 2 such that these coefficients become equal, and then subtract, and rest of the things we'll multiply and subtract in the same way, and we'll get the equation. Okay, that's it. That's simple, right? So this is what we were trying to do earlier. Okay, so we were saying I find this method to be way more obvious, the recursion one. The recursion one is simply, you have, let's say, n number of equations in n variables. And what you do is, the moment you realize there is only one equation left, all you do is, and the equation will have right-hand side and the left-hand side. So you will divide the right-hand side by left-hand side. That will be your answer. Okay. So you return the first variable like this. Or last variable like this. So this is your last variable, like y will be like this. So is this clear, this part? If you have one variable equation, what do you do is you pick the equation, assign it to a and b. So you get 30 and minus 3, and 30 divided by minus 3, you'll get 10. Right? So this will look like, the equation will look like this in here, -3 and 30. This is how the equation will look like. Okay, example would be like this. So equations will look like this. Okay, there's only one equation, right? And the coefficient is -3 and value is 30. Answer is, so I picked the 0th value, which is this, and assigned it to A, comma B, and then return. Is this clear, everyone? This part? So if I have only one equation, I can solve it like this,
Yes.
right? And now, what we got to do is we got to, let's say now we have, let's say, 2 variable equations. Okay, let's just think of 2 variable equation. What will we do? We will eliminate the first variable. Okay, so we picked the first equation. So we picked the first equation, 2, 1, 10. Okay, and so this will be like let's say 2, 1, 10. Okay, and right, so, and what did we do here? Yeah, so we said we are picking the last value. For some reason, we are just picking the last value. Should we pick the first value instead of last value? What do you say? Here we are saying -1 is this, -2 is this. So we are picking the last variable. That's okay. We can also pick the last. Or do you want to pick the first one? Let's just carry on with this first one. So we are saying we pick 2. Okay. Now, from the next equations, we go over the next equation. Let's say this is my next equation. Okay. And what we do is we figure out what number should we multiply the next equation with. Okay. Or what number should we multiply our first equation with. So here we, instead of multiplying the next equation with something, we are saying that we should, okay, let me see what we're trying to do. Okay, so what we are saying here, pick all the equations, right? If there are 3 equations, we will pick, except for the first one, we pick the other 2 because we'll subtract from the first one. Okay, subtract the first one from them. And we figured out here, we are saying, okay, pick the 0th variable, like here, 1. In example, this is 1. Now we got 1 here, this is 2. So 1 divided by 2, LC2, this is 1, this is 2. Okay, now we are saying we are multiplying the next equation with this multiplier, which is actually wrong. We should do this other way, right? LC2 divided by 1, right? LC1 is 2 and LC2 is 1. So we got multiplier as 2. Okay, so this divided by this, that's what we did. And then we multiplied this equation, the next equation, with the multiplier, and subtract the first equation. Is that okay? Now, this needs to be done in a loop, isn't it? This needs to be done in a loop. Correct? Okay. So the new next equation, let's just say next equation is this. Okay. So what we are doing is for each value in the next equation, what we are doing is we are calculating the next values. Okay. All right. So what we are doing is, okay, and the first value is going to be 0, right? So we can always say this, right? First value is going to be 0, right? So we are only picking the first value onwards, right? So we are saying next multiplied with this multiplier minus the, okay. Also, we will have to do is enumerate. Okay. How would you do it? Anyone? We will have to do is say I equals 1, and we will say for I, okay, while I less than length of next, right? We will keep on increasing I, okay, and we will say the new next one append next multiplied with mult minus the first equation, okay, and I, okay. So that gives us the new equation, right? And what we got to do, we will just append this new, we'll just append this to new equations. Does it look okay? Anybody wants to review my code? No? No? I made a mistake.
Don't you need to increase I? Yeah.
Thank you. Okay. So, do you see, is this part clear to all? This one? So if my example is this equation, minus 3 and 30, the answer is B divided by A. Make sense, everyone? And then what I did was, let's say I have an equation like this, right? Let's say this one, 2, 110, and 1, 1, 0, 1 minus 1, and so on. So there, the next equation might look like, 1 minus 1 and 20. I'm just taking this example, 1 minus 1, 20. And then this is my first equation. And what I'm trying to do is, right, I'm saying pick the first variable, that is 1. Then I'm saying multiplier is equal to LC1 divided by LC2. LC1 is 2 and LC2 is how much? 1. So 2 divided by 1. I'm going to multiply with this number the whole equation. Okay. And how do I do that? Since what I'll do is I'll multiply this equation with 2 and subtract the first equation. And since the first value is going to be 0, therefore I'm going to keep only from here. That's why I said I equal to 1, I less than length of the next equation. After doing this whole calculation, everything will be stored in next one. So I'm saying next one dot append. Then I'm saying next I, okay, next I, the one that I'm doing right now, next I, minus, multiply with mult, then subtract y by first equation, and then I'm increasing I by 1, and there we go. Does it make sense? So I, right, reducing the n equations to n minus 1 equations. Okay. So if I have 100 equations, it will convert that into 99 equations. Isn't it? No?
Yes, Sandeep.
Yes.
All right. All right. Keep eyes open. I would make mistakes. Help me out. Help me fix those. Okay. All right. All right. So no matter how many times I do this problem, I'll have to think again. And that's a good thing about good problems in computer science, that that you know basically it would basically make you think again. Okay. You won't I mean you won't really memorize things. Okay. You can't really memorize this. Now, this now look at this. Now we are assuming that this thing will solve for n-1 variable. Okay. Now, if you know how much is y, can you figure out x using the first equation? You have the first equation, right?
Yes, Sandeep.
Can you figure out, so you know this is 2x plus y equal 10. Using this, can we figure out x? So what we got to do, and let's say if you have let's say 3 variables, 2x plus 3y plus z, and you know y and z, you can figure out x, right? So all you got to do is multiply this with the value of y and so on, rest of the variables, and then sum up all of those values, subtract from the last one, and that's about it, right? And divide by the coefficient of the first one, right? So what you do, I equals 1, while I less than length of first equation, right? First equation. So what I'm doing is I'm putting y in this, okay? Y in this, okay? So I'm saying I'm going to go from y, z, and so on, all the variables. Okay, each one I multiply with the coefficient. Okay, right, I'll say total equals 0. Okay, like the answer would be x plus 2y plus 3z plus 8u equals 20. You are given y equals, right? You are given y, z, u is equal to, let's say, 1, 2, 3. How much will be x? X will be equal to 20 minus total, like total of, or you can say, right? You can also say total of 2, 3 multiplied with 2, 3, 8 multiplied with 1, 2, and 3. And divide the whole thing by the coefficient of x. Let's say coefficient of x was, let's say 2 here. So not 2, let's say 3. 3. So you'll divide by the coefficient of 3. Correct? Is this okay? So 1 into 2, like that. Is this okay? If let's say you have these variables and you solved for y, z, and u, okay, that solution will contain all the variables, one less than this. And then what you do is you substitute these values here, compute the total. Okay, let's just compute the total. Let's just compute the total. I'm starting from first position, going for less than 1. Okay, I'm going for less than 1 here. So it'll just go till here. Okay, and I'll say total plus equal to first underscore equation at ith location, whatever is the coefficient, multiplied with solution I. Okay, okay. This is little disturbing. Let me think. Because solution will be like 0, 1, 2, and that'll be from 1 to 3. So I can say I minus 1. Okay. And this will compute the total. Now my variable's value is going to be, well, variable's value is going to be how much? The first equation's last value minus total and divide by first equation and 0. Cool. Now we'll just put this into the solution, right? So we'll return val plus solution, right? If you remember correctly, right? If you have 1, 2, 3, 4, right? You can just add them like this. Okay. So you have like, yeah, making sense, everyone?
Don't you have to change the I value after 29?
Don't I have to change the I value? Yes. That's one of the biggest mistake I always make. Okay. Do you think it'll work?
Also, I mean, when you're recursively calling it, right? How does the length of the equation keep on reducing?
This one, right? See, here, if you see, we are iterating over one less equations, you can see.
Okay. Yeah.
Right?
Yeah, sorry. Got it.
Since we are iterating over one less equations, this will be, new equations will be one less equations. Okay. And the solution is increasing the length by 1 every time.
Sandeep, can we also try to solve this with the help of determinant? Because I think that will be easy to code and understand.
Yeah, is it? I thought this will be easy.
Because in that we only need to find a determinant of x and divide by determinant of variables.
Yeah. No, determinants are good if you are trying to first figure out whether it is solvable or not. Okay.
Solvable or not means?
Because there could be equations, right, which are not solvable. So determinants are used there, right? Otherwise, you use Gaussian elimination. Isn't it? All right, let me try again. So, all right, here, which part is not clear to you here? So I'm just doing it very naturally, that if you have 3 variable equation, convert it to 2 variable. If you have 2 variables, you convert it to 1 variable, and then solve it for 1 variable, then use that to find the next variable, then use those 2 variables to find the third variable, and then you keep on going. Not clear? Yeah. So let me take a step back. So how many of you have solved the equation per se, like x, y, and right, in 2 variables? How many of you can solve it in 2 variables? Everyone can?
I mean, we can solve, but the method which I remember is slightly different. But yeah, I mean, we can solve.
I can solve that too.
Yeah.
Yeah. Yeah, I can solve two.
By elimination method, right? You keep on eliminating one variable at a time.
Yeah. Yes.
One
Yes.
variable. Yes, yes, yes.
Okay. Okay. Perfect. Perfect. And yeah. Okay. Cool. So yeah, this part, is anybody having doubt? And how many of you think that it is solved? This can be solved. Should we try it out? Oh, it just failed. Okay.
Mhm.
Okay. Let's just solve these syntactic issues. Okay. Let's test it out. Do you think it'll work on this particular problem? Okay. Let's see. How would you represent this problem? 2, 1, 10, right? And 1, minus 1, 20. Is this right? I'm representing these two equations like this, putting them in an array.
Yeah.
And there we go. So this is my equations. Okay. And I'm going here and this is my equations. And I'm saying solve underscore equations. And let's see what happens. It says new equations are not found. So there is a typo. Do you see a typo? This. Okay. All right. It says list object is not callable. Okay. Why it's not callable? What did we do? What did we do? We are supposed to append the next here. Okay. First equation is not defined. Where is the first equation? Here. All right. Did I solve it? Y is minus 10. Yay. Y is minus 10. X is how much? X is 10. Wow. Yes. So it worked. Not bad. Not bad. Two equations is working. Do you want to try three variable equations? Okay. Let's just try three variable equations. I'm going to just randomly put things. Okay. And all right. Is there a website which can solve these equations?
ChatGPT is also.
Really, it works?
Yes.
Okay. Wait. One more equation I have to put. I'm just putting random numbers. Okay, so there is a division by 0. All right.
I can give you a problem with site, right?
Yeah. Can somebody give me a good example? I know there's a bug in this code, and I want to address it just after this discussion. I just want to test it without that. There's a class of problems that it can't solve, and there is a division by 0. Here you can see that there's a division by 0, right? So what you got to do is here, make sure that this position is never 0. If the first variable, this one is 0, then it'll be division by 0. So what you got to do is, if this variable comes out to be 0, swap it with something which is non-zero. Okay, so what you do is here, if first equation, okay, all right, right? Okay. And we will say, we'll just replace those variables. First equation is this, while first equation, and how should we do? Okay. Okay. While first equation, okay. All right. We will keep on going through it so we can, yeah. Can you give me the problem? I'll come back to this one again. So what we'll do is we will try to pick where the 0th value. See, what's happening is this LC2 is 0 in this equation, right? If LC2 is 0, then there'll be a division by 0. Okay, that's what is happening. You see, LC2 is 0. Okay, so all right, and again, in why does it say not enough values to unpack?
There's this 4 equation. We need 5 coordinates then, right?
We have 1, 2, 3. Yeah, this is it. Yeah, it solved some, it gave some answer. Okay. Okay. So it does work. It does work. There is a bug in the code that we got to rectify. Okay. And the bug is if you have, let's say, the equations look like this, right? The equations, let's say, y equals 10 and x plus y is 20, right? So in our code, this is 0x, right? And then we are trying to figure out what to multiply the second one. That's why it's failing, correct? So if you have the situation like this, okay, then it's kind of failing. Got it? All right. So what we will do is we will essentially here, okay. What we will do is we will, right? Okay, we will okay, what we will do is we will try to go over all the equations, okay, while I equals to 0, and we'll say while I less than length of equations, okay, if equation ith equation's 0th place is not equal to 0, we break, and we increase. Okay. All right. All right. Okay. Am I making sense here? So, and then we will say, right, okay. So we'll swap. Okay. We'll say first equation equals E, Q, and S at ith position. So we'll pick the ith location, and then we'll say at E, Q, and S at ith, we will put E, Q, and S 0th. Okay. And we will put E, Q, and S 0th equals first equation. Okay. So here what's happening is we are saying find the first equation. Find the equation where first coefficient isn't 0, and swap it. Swap it with first equation. That's it. All right, that's it. And okay, so now even if I go back to where it was throwing error, it'll work fine. Okay. All right. Why did it not work fine?
I think
Because
we can also calculate LCM
I
instead of
think,
dividing.
okay. Yeah, I think this equation is anyway not solvable, I think. All right. Yeah. That one is not, I think, not solvable, most likely. And why it's not solvable, let's see. So what we did was we took this, okay, multiplied the second equation with, let's say this became 2, this became -2, this became 8, this became 40, right? So when we subtracted it, this became 0. This became how much? -3. Then this became 3. And this became 0, right? And then these two things, what will happen is when we subtract from the next one, this will be 0, 0, and 3, and 30. Okay, so we are left with these two equations. Okay. Okay. This is easier. This is easier. All right. So I'm saying keep going over the equations. Go like if the I is less than the length of equations and ith equation's 0 value is equal to 0, keep going, otherwise break. Okay. So I'm just wondering what's happening here. Look at this. So what's happening is we are basically, okay, so this divided by -3, that's 0. Okay. So if this is 0, what will be the multiplication? So if this is the situation, right? If we are having, let's say, these two equations, how would you solve them? I'm just thinking if my approach is right. Everybody, please feel free to tell me. So if you have, let's say, two equations, x plus y equal 10 and y equals 5, we can represent it like 1, 1, 10, and this is 1, 5. Now, this is anyway 0, right? This is anyway 0. So we are saying this divided by 1, that's my multiplier. So multiplier turns out to be 0. And what we do is this minus 0. So I get 1. 5 minus 0, I get 5. And this should work, right? I'm just wondering, like, would it work? Would this, if I feed it equation like this, okay? X plus y equals 10 and 0, 1, and 5. Okay. Shouldn't it work just like that?
This LC1 is the first equation's coefficient, and second LC2 is the second equation's first coefficient, right?
LC1 is first and LC2 is second. Okay.
Then
LC1 is the first equation. Yes, that's correct.
then in that case, we are multiplying by 0.
Multiplying
Our
by 0.
second equation's first coefficient is 0.
Shouldn't it be? What did I do? Did I make a mistake here? So, good point. Good point. This, how do I figure out, like, whenever I'm saying 2x plus y equals 10 and x plus y equals to 5, this divided by this is the multiplier I have, right? Okay.
Instead of division, if we calculate LCM, it will be easier.
LCM? No, the division by 0 will be there even then, isn't it? So what if we do the inverse? So instead of this, if we calculate, like, what number should I multiply the next value with? Okay. If I figure out, instead of that, if I say, what number should I divide this with, right? So I should divide this by 1 by 2, correct? I should divide this by 1 by 2. And let's say, okay, and I call it div, divide by 1 by 2. And here, instead of multiplication, I do the division. Okay. And where did it go next? Okay. All right. Again, it's not doing well. Wait. So what I'm trying to do is I'm trying to do LC2 divided by LC1. Okay. And then I'm so wrong. Next equation minus first equation multiplied by division. Yeah, multiplied by division. Yeah. I think this makes sense now. So what I did was first equation multiplied by a number, like what should I multiply with? And that's about it. And the first equation will not have this division by 0 will not happen because I have made sure that LC1 is not 0 by doing this. All right. That's it. Okay. Now, there is one condition that all of the coefficient in the first column are 0. In that, there is a problem. Okay. So if I equals length of equations, okay, then you basically say return none. Okay. And you can just print no solution found. Okay. Something like this. Okay. And you have to deal with this situation. All right.
Will this also take care of cases where the solutions can't be solved? I mean, if the three plane doesn't intersect, then that means that it cannot be solved, right?
Yeah. This will take care of that. Because that will happen if, let's say, we are saying x plus y equals 10 and x plus y, 2x plus 2y equal 20. What will happen is this will become 0. Okay. There is one more situation that we need to handle here where a is 0. Okay. Right. If a equals 0, then we return saying none, and we'll basically print can't solve it. Okay. Ideally, you should basically throw a new exception, throw exception. Can't solve it. Got it? Something like that. How do you throw exception? Right? Throw exception in Python, right? Raise, it's called raise, not throw. Okay. Yeah. So you can just raise an exception. Okay. Here also raise exception, and that's it. So if you ask this one to solve an equation like this, okay, it would say can't solve it. Okay. So it'll just raise an exception called can't solve it. Okay. Is this good enough? Did I make sense, or is everybody zoned out?
Sandeep, if you could just go through the whole code like again, like that would be like great. I feel. I'm still like kind of figuring out the recursion side of this pretty much. I know the first part is like the recursion, but how you have integrated into the rest of the formula is what I was looking to understand a bit more.
Okay.
Yeah, I mean, plus one to that, I got how we are solving it. I got chunks of it, but there are few areas. Yeah, I mean, it would help.
Okay. Okay. Anybody else? All right.
Sandeep, actually, I'm also getting like confusion in this topic.
Okay. Okay. All right. All right. Yeah, please feel free. Raise your hand if you want me to repeat it.
Yes, Sandeep, I think I'm finding it hard to connect myself with the manual and the coded way of things actually. So both things are not coming in my mind together actually, and hence I'm getting confused.
Okay.
Yeah, when you were doing it up, I was trying to solve it out on the paper.
Okay. I see.
Yeah.
Okay.
Sorry for that.
Okay. So, all right. I think, okay, let me here. Okay. Please raise your hand if you want me to do a 3-variable equation manually.
Everybody raise hand before complete the question. Everybody raised hand.
Okay.
Question.
Yeah. Please raise your hand only if you feel that I should do that manually before going to the code. Okay. All right. All right. So 9 people want me to do it. Okay. All right. So should I start with let's just solve it manually, and probably you'll start to get the feel of it, and then we will do it using the code. Does it make sense to everyone?
Yes.
Yes.
Yes, Sandeep.
So there are 3 parts to the problem. Number 1, doing it manually. Number 2, handling the recursion. And third one is how did I handle the case where the two planes are non-intersecting or 2 planes are parallel, right? essentially two equations are canceling each other and everything is 0. How am I handling that? And yeah. Okay. Perfect. Just give me 3 good equations. Who can give me 3 good equations to solve? This one looked nice. Okay. This one looked nice. Okay. Yeah. Should we take this one? This one seems like simple to calculate. Okay. So these are my 3 equations. Okay. These are my 3 equations. How do you usually, so basically this, okay. These are my equations. Okay. Now, and all right. All right. So essentially, let's look at, how do we solve it? So we have, let's say here, okay. So what? Why is not working? Okay, now it's 2x plus y plus 5z equals 40. 2x minus 2y plus 8z equals 40. And 2x plus y plus 2z equals 10. Is everybody clear about these equations?
Yes, sir.
Yes, indeed.
Okay. So we have represented this as 3 cross 4 matrix, right? So 3 rows and 4 columns, correct? And the way we represent it in Python is that it's a list of lists, okay? It's a list of lists, right? Now, using the first equation, we will eliminate x from the second one. So this is my equation number A, this is B, this is C. So we say B minus A, right? That way we'll eliminate x from the next equations. So we are left with what? We're left with minus 3y plus 5z equals 0. Is that right? Minus 3y, 3z. No, this is
minus 3y, 3z, right? Yeah.
Plus 3z, right? And then we say c minus a, which is basically, which is what? Which is, again, x get eliminated. We just multiply by 1. So we can say 1 multiplied with a.
Somebody telling you use the Excel just to make it clear. Or if you're okay with Notepad, go ahead with fine.
My handwriting is not bad today. Okay. Yeah, I'll try my best to keep my handwriting good. Okay. Yeah. Okay. So now I think it's a good idea to do it in Excel also. Okay. Now we say C minus 1 times A, which is like X get cancelled, and we have Y minus Y. This is 0. And interesting. So, okay. And we are left with 2Z equals 0. Okay. Is everyone okay with this? Sorry, this is going to be 10 minus 40, which is minus 30. Okay. So now we got.
Is it minus 3z or?
3z.
Okay. Okay. Oh yeah, this is 3z equals how much? 3z equals minus 30. Okay, so we have D and E, and we are trying to solve it for Y and Z, right? Now we are seeing that we basically subtract from this first equation with the 0 as multiplying. So D times 0, E minus D.
Sandeep, just one quick question on the previous one. Is it 3z or minus 3z?
This one?
Yeah, the second equation.
8 minus 5 is 3. 2 minus 5 is minus 3. I think you are right. Okay. Now, here if you see, the coefficient of y is 0 times y minus 3z. Okay. So to eliminate y, we don't have to do anything. We just have to multiply first one with 0 and subtract with that 0. And what we get 3z equals minus 30. We got z equals 10. Good. Now, so in the first situation, we had three variables. By doing subtraction of second one from first one and third one from first one, we eliminated x completely. So we are left with two equations with two variables. Then we eliminated the first variable y, and when we eliminated first variable y, we are left with the only one variable equation. And once we have one variable equation, we know how to solve it. Divide this value by this. Okay. Then we solved it for one variable. Now we go back here. We say, okay, we are given one variable 10. We put 10 here. Okay. We put 10 here. We are going back from now. So we put 10 in that. Then we get y equals minus of 30 divided by minus 3. Correct? And it turns out again. I just put this in the first equation. Okay. In D. I basically took this equation and put it in this equation. Okay. The D equation. Make sense? Let that sink in.
Yeah.
So from here, yeah.
Sorry, the D equation can be further simplified, right? I mean, it won't matter, but
we don't need to
simplify.
We don't need to simplify.
Okay.
Our sole objective is to keep eliminating one variable, reduce the problem by one, and then keep moving. Though it can be simplified. Normally in algebra exam, I would simplify it. Okay. All right. So when we are calling the recursion, right? So 3 variable to 2 variable, 2 variables to 1 variable. Okay. And from 1 variable, I go back, put this value back into here, calculate y. Now what I got here, I had z equals to 10. Now I have y and z equals 10 and 10. Now I put in this one. Let's put it in first equation. Okay. And based on that, how much is x? X is equal to 40 minus 10 plus 50, that is 60 divided by 2. Right? So minus 10. So x is 10. So first from top, I went reduced variable by 1, then again 1. And when I left with one variable, I solved it. Then I went back up, put in the first equation, calculated one extra variable, went up, calculated using these two variables, calculated third variable, and that's it. So the process is pretty simple. Process is simple. What you did was essentially it's a recursion step. Okay. So you had 3 variables, you converted them 2 variables, and then you converted to 1 variable. And then from 1 variable, you converted it to 2 variable. From 2 variables, you converted to 3 variables. The solution, right?
Yes, and this makes sense. So if you switch back to the code, just using the same equation,
Okay.
if you can walk us through the recursive logic back and forth, like from 3 to 2 to 1 and then back.
Yeah. I want to do one thing. I will just take the screenshot. Okay. Okay, I've taken the screenshot. Now I can easily copy this. Okay, I'll just clear the whiteboard. Okay. All right, so let's open this recent files. Yeah, now. Okay, everybody can see this now. Now let me just keep switching back and forth. Here you go. Okay, let's start from here. Okay, so we have equations. How many equations we have? 3 equations, correct? So our data looks like this. Okay, our data looks like, where is that equation? This one, right? This is the equation. So we have 3 equations. You can see it's an array of arrays, right? Array of arrays of values. Okay, now we go back up here. Is the length of equation 1? No, right? We go in the else block. Then we basically here, what we are doing is we are trying to find an equation which does not have the first value as 0. So we check this one. Yes, the first value is not 0. So it breaks, and that's it. So I is 0. And here we are checking, is I more than the number of equations, right? If it is, you can see it. If it is greater than or equal to the length of equations. Length of equation is 3, and the index can go up to 0, 1, 2, up to 2, not 3. Okay. If it went beyond, that means no solution found, meaning all the equations have zeros at the coefficient at the beginning. Okay. If you have, let's say, 2 equations given as y equals to 5 and y equals to 20, then those are inconsistent because x is missing from those 2 equations. Okay. Now, if that is not the case, okay, if that is not the case, then we move ahead. Now, basically, we try to swap the values of these equations. What we do is imagine that we are given, say, 2 equations, right? 0x plus y equals 10 and x minus y is 5, right? So usually what you'll do is you'll swap their positions, okay? So that you can subtract the first equations comfortably and then pass it on, okay? Therefore, what the usual technique is that if the first coefficient is 0, right? If the first coefficient is 0, just swap it with something non-zero. And that's what we are trying to do. Yeah. So here, when we were looking for the equation with the non-zero, right? We keep on moving as long as the first coefficient is 0. And then we stop the moment we find non-zero. We basically here, we are doing the swap. This is where we are doing the swap. Okay. Swap the first equation with non-zero. Okay. Is it okay? So far, so good? Yeah.
So if you bring the screenshot back, what does this mean? Swap the first equation with non-zero first coefficient.
So what we are trying to do is, if let's say we end up with this kind of equation, right? Y equals to 10 and x minus y equal to 5. Okay. And if I ask you a question that what number should I multiply the first equation such that we can eliminate the first variable, it'll become divide by 0, right? Therefore, what you do usually is you basically bring this value up. You swap the order. Okay. Like if let's say you are given the three equations, right? Y plus z equals 10, and then x plus y plus z is 5, and you are given x minus y plus 2z equals 20, right? Now, if you try to figure out what number should you multiply with first one, what will happen is there'll be a division by 0. So the technique is just swap these order. Okay, that's it. Swap the order such that the first value is non-zero. Yeah.
So this is more like handling an exception, not really specific to
Exactly. Exactly. This is basically for handling the divide by 0 cases. Okay. This is for that situation, right? Now, even if earlier this logic was not there, therefore we were all fine. Now we have the first equation. Okay, we picked the first equation, and now what we're going to do is we are going to eliminate the first variable. Like we chose first equation like this one. Okay. So our first equation is 2x plus y plus 5z. Okay. This first equation is 2x plus y plus 5z equals 40. That's our first equation. Next equation is we are iterating over each of these. So next equation is right now 2x minus 2y plus 8z. You can see next equation in equations 1 colon, meaning pick all the equations from first index onwards, one at a time. So next becomes 2x minus 2y plus 8z equals 40. So that's our next equation. We find out the first value of this, that is LC2 equals 2. Okay. And then we say, what number should we multiply with? We say LC2 divided by LC1. Okay. Meaning 2 divided by 2. That means div turns out to be 1. And then we are saying here, what we are doing? We are saying multiply the first equation with 1, and subtract from the second equation, b minus a. Why we are doing this? So that we can eliminate x completely. So we eliminated x completely by doing b minus a times 1. So we are saying b, this is b minus a times this value, right? So we said b minus a times 1. Now b is a vector, so we have to go over, b is a list of numbers, so we go over each value and subtract it. Make sense, everyone?
Sandeep, just one question.
Yes.
Why be doing a division LC2 divide by LC1? But when the coefficient of both the equation are same, then how we are checking whether the coefficient are same or not?
We are not checking. It'll be like 2 by 2. So division div will be 1.
So so Sandeep, in our equation, because both the coefficients are same, right? 2x, 2x. So
Yeah,
still
yeah.
do still this is a valid in this case also, because we can directly subtract first equation to second. You can get two variable, only y and z, because x is already eliminated.
Correct. So otherwise we'll have to put one more condition saying if first coefficient equals second coefficient, then so there will be unnecessary one condition, but this can handle both the situation.
Okay.
Okay.
Got it.
It's unnecessary, redundant, but it's saving our number of lines of code.
But Sandeep, there are chances your x coefficient may not be same, like 4x and 2x.
Exactly. So 90% chances they'll be not be same in the equations. It's only very rare cases that they'll be same. Okay. So we don't want to just write extra line of code for that situation because we can generalize it, right? All right. So if both are same, then it'll be 2 by 2, 3 by 3 or whatever. So div will be 1 and we'll multiply the first equation by 1 and subtract it from the second equation. And whatever is a result, we kept it in a new equation. This is our new equation. And we do that for all the equations and prepare new set of equations. These are my new set of equations. And then we are calling recursively the same function. Okay. Now, when we call that recursively second function, that basically will repeat the next process. So from 3 to 2, 2 to 1, it'll do the job. Okay. Is the recursion clear?
So why we are using append here?
Because we are preparing new equations. Got it. Where there are two appends. One is line number 37 and other is 39.
Yeah, so 39 one I was trying to understand.
Okay. So basically we prepared a new equation. This is my new equation by putting each of these values, and this new equation, we put it into the new set of equations. So this is here. Okay.
Sandeep, could we print and see what exactly, like I wanted to understand this to append statement, what exactly is doing there?
Okay. Okay. You want to see this? No, this is essentially, if you see, I'll just show you.
Sandeep, sorry. Isn't it just creating, I mean, appending into a next one, and then just the entire next one is appended to new equation, right? That's it, right? So that's what it is doing. Just creating the list, creating a sort of a group in the while loop, and then adding it to the new equation. That's it, right?
Basically, this process that we did here, when we said b minus x1, that is what happening. We are saying minus 2. So 2x minus 2, that is 0. We are not touching that. We are saying 2x minus y, then we kept 3, then 8 minus 5, we got 3. We have 40 minus 40, 0. That's what is happening. This minus first equation times div, all right? Each variable we are doing one at a time. You see that? We go from left to right, keep on filling that. Got it?
So Sandeep, just to understand the flow, basically, let's say from line 31, first it goes through the second equation, and it basically finds what could be divisible. And then you pretty much do the multiplication, like you said, and subtract it, and that gets appended. Then the third equation, it does the same, since it starts from line 31 again. And those two is what those two solutions are basically appended into new equations, and from there is when you use the recursion side.
Yes.
Right?
Yes. And from those two equations, next time it'll turn it into one equation, and then again it'll solve equations with one equation, and then it will hit here in case of equation R1, and then it'll solve it and then give back you the result here. with one variable. Then this logic will turn the solution from 1 to 2 variables, and then we'll go back. Got it?
Okay, yeah.
So basically, if you have 4 variables, first it will reduce it to 3 variable, then 2 variable, then 1 variable. And when you hit the 1 variable, it'll go to this particular logic here. Here, it will return an array of 1 variables as a solution. Okay, this will return a 1 variable solution. Then here it will add 1 more variable to it. You see, solution plus 1. Okay, it will add 1 more variable to it. Then it will give 3 variables answer, and then 4. So this will be your solution. This is your input equation. So, okay, you see that? Here, this loop is preparing how many equation? 1 less equation, right? Equation 1 colon, meaning second to the end, pick all these equations and subtract the first one from them after multiplying a multiplier such that first value is eliminated, and that's about it. You see that? Okay. All right. So the way you can probably imagine this whole process is happening again is like this. Okay. If you have a big matrix of numbers, it has some values here, some values here, some values here, some values here, some values. Okay. Okay. Now, what it will do is it'll take the first equation and it'll basically eliminate these values. Okay, these will become 0. So now you got only this small problem. Then using this equation, we will eliminate this, make it 0. Then we are left with, did I? 1, 2, 3, 4. 1, 2, 3, 4. So we eliminated these two, and yeah, we are left with these 2 equations. And using the first equation, we eliminated this variable. Now you're left with 1 variable. This is 1 variable equation. And once we solve this, we find this value. We solve this variable. We basically solve these 2 variables. Using these 2, we solve these 3. And then using the 3 variables, we solve the 4 variables. Okay. And there we go. Is it making sense? Do you still find Gaussian elimination simpler than this?
At least I don't know about others, but I think I need to put my heads around this for 2-3 times to get things right.
Okay, thanks for being honest. Thank you for being honest. But yeah,
sorry, I'm be honest. Yeah.
Huh? So
no,
yeah.
What I was saying is I'll be brutally honest with myself. Like I need to put my head around it. Yeah.
Okay. All right. Perfect. Is everybody?
Sandeep, just a small question.
Yeah.
So in this recursive way, if we pass a array which is already Gaussian eliminated below that major diagonal, will it still work?
I think it will work because it will eliminate basically the zeros and it'll work fine.
Okay, even in the time for whole array, if you are having all zeros under the major diagonal.
Yeah, we can test it out, no? We can
Yeah,
test
yeah.
it.
I was curious to. You want me to give the values?
You can just do it.
Okay,
random.
okay. Yeah, sure. Thank you.
Yeah, that's a good question. Let's just give it a shot. Let's say this one we have x plus y is 10 and 2y plus equal to 5. So it is working fine. Even if these are like in here, this would work. Okay. The previous version worked for this.
Okay.
All right. So this is a good solution. The only problem with a big problem that you see here is this. Okay. A big problem with this is that every time we are creating new array, you see new equations are being created and put into this and then going ahead. So it's taking too much memory, right? Okay. Ideally, that's not really needed. When we are subtracting, if we are subtracting in place, right, we could just pass that new equation and tell from which index to which index we are interested in. Okay. I comma j we can pass so that it can just take the offset from there rather than creating new instances. So that we can be eliminated easily, this extra memory use case. That's the only downside I see with this approach. It's taking too much of memory. Okay. Gaussian elimination is way more efficient when it comes to memory and other things, but it's another way, you know, I feel that if I did not know Gaussian elimination, this is how I would do. Okay. I don't want you guys to memorize the Gaussian elimination. I want you to do the way you have been doing. Okay. So yeah. That's why recursion is way more natural. The way we have been doing things, the recursion is very much like that. Okay. And yeah. Any questions on this? Rahul, if I can help you right now, I can explain further. But this is something that is needed, right? You might yeah, Dane.
I got the basic sense. It's all about like, combining it together, like the manual and coded way actually. So I'll put my headset on. Hopefully today. If not, then maybe I'll ask the same question next week. Okay.
Okay. So why I emphasize a lot on the matrix solution, because there are many use cases where this will be used in future. Okay. One is normal. There is something called a normal equation when we are doing linear regression, any form of prediction. The equation solving is used. Other is, let's take another example where we are solving. Let's take a case of a bicubic manipulation. What does it mean? Now, there is it's a very important problem. Okay. So when you think about auto scaling on Amazon or anywhere, right? What does it auto scaling do is, as the load is increasing on your server, you increase the number of servers. Okay. So you need to predict, you need to predict what would be you need to predict quickly the traffic expected in the next step. Okay. So usually what people found is that when it comes to doing it extremely fast, right? People realized that there is a square kind of situation. Okay. Like let's say you are given the traffic at time equal to 1, time equal to 2, and time equal to 3. And using this, you have to predict the traffic at time equal to 4. You're supposed to predict this. So people realize that usually the traffic follows a different equation. We call that y equals to a x square plus bx plus c. It follows a quadratic equation. Okay, so where x is the time and y is the traffic. Okay, so let's take a case of this one. Say you are given that at time equal to t1, the traffic was 5. At time equal to 2, traffic was 8. Time equal to 3, the traffic was 12. At time equal to 4, traffic was say 30. Okay, this is the data you have. 5, 8, 12, 30, right? So let's just put these values into this. Okay, we are given 5 equals to a plus b plus c, and 8 equals right, 4a plus how much, 2b plus c, and at here 12 equals to 9a plus 3b plus c, and 30 equals 1, 2, 3. I think you'll be given 3 equations, not 4, sorry. You're given only 3 equations, and you have to predict the traffic as t equal to 4. Okay, at t equal to 4, what is the traffic value? Okay, now can you solve this equation quickly? Yeah, should I test it out? Okay. Let me just write the equations. Okay, equals how much? All right. So let's say we are given the value of y equals how much? 5, 8, 12, and that is my value of y. Okay, and the value of x is how much? 1, 2, 3. Okay, and then we are saying, right, what we are doing is we are saying like coefficients of each one. Okay, so we are saying, okay, let's say define coefficients. Okay, for x in x. Okay, and what we're doing is result. Okay, result dot append. All right, underscore x square comma underscore x and 1. Okay, and that's about it. So we have the result. So 1, 1, 1, 1, 1, 1 equals 5, 4, 2, 1, 9, 3, 1, 12. Correct? And we can also say here, okay, this is, how should I do? What am I doing? All right. Result, I'm just preparing the data, that's all. All right, let's do. So this is my equation. So 1, 1, 5. These are the 3 equations I've represented. 4, 2, 1, 8, 9, 3, 1, 12. And I can ask my solve equations method, right? I can say this, and it has solved it, right? So my equation turns out to be this, okay? And I can just say equation equals this. And now I can say my method called predict. Okay, I can define a method called predict, which takes this equation and which takes the value of x and returns essentially the resulting value of this. Okay, so how would I do? I will say whatever is the equation that I have here. Okay, so I'll say what should I do? Okay, and yeah, so essentially whatever is the equation here. Okay, so I'm saying 0 times x times x. Okay, all right, so now this can do any prediction of the load. Okay, now I can just say equation and I'm passing say 4. Yeah, so answer is at t equals to 4, it is saying it'll be 17 will be the load. Okay, and similarly I can just predict for say t equals to 4, t equal to 5, and it'll tell me. All right, so what we just did was, this is called bicubic, I think it's called bicubic approximation. Essentially, essentially we did a very, very simple thing. We went with this equation, y equal to x squared plus bx plus c. We put we assumed that we were told by somebody secretly that mostly the traffic has this, rather than y equal to bx plus c, it is ax squared plus bx plus c. And we are putting x into this, and we are getting these values. Then we solved it for ABC. Once we found the ABC, we say, okay, our equation is going to be a times x squared plus b and so on. And then we can put the time value and it will predict the load. All right.
Okay. Yeah.
So this is something when you go to industry, this will be kind of these two methods. Okay. These two methods that we did here, fit and predict. Here, the fit is nothing but solving the equations, and predict is nothing but multiplying this. Okay. This is a model. Okay. Is everybody okay with this?
Yeah.
Can you frame your code, okay, into this? Okay. Like you take the data in a quadratic form and you define your class name, constructor. Then there is a fit method which takes x and y. Then there is a predict method. So this fit learns from the data, and predicts given the x. Okay. Can you do it for quadratic now? And can you do it for you use this library function called solve equations to do multiple data points, like multiple dimensions x, y, g, and u, and so on, as well as this. All right.
Yeah.
So yeah, design your library, and I think that will make you really, really confident with this.
Yeah.
All right. And I hope you guys are finding this class useful. Okay.
Yeah.
Yeah. See, these things are hard, but if they were easy, then I wouldn't be teaching.
This is good stuff.
Okay, thank you.
Yeah, and that's a different way of thinking, but yeah, no, that's what we are here to learn.
Yeah, because I think the rest of the things, the general Gyan and everything, you can get anywhere. But I think this is something that you wouldn't really look at usually. The moment you'll see in normal workflow of our day-to-day job, the moment we see a formula, mathematical equation, or a code, we usually turn off. Okay. And
Yep.
that's why. All right. So I would want everybody to design your method, like the class with fit and predict, and such that you have these two algorithms. One is the quadratic and linear both, and do it. All right. I will commit this code and it will be available to you. All right.
So, Sandeep, can you repeat? Can you repeat that? So
Yeah.
create a class.
Basically, what here we did in a very unstructured manner, right? So I would
Okay.
expect you to design your class. Okay. Your design a class like this. Your class name, there has to be a constructor which initializes some values. Then there has to be fit method, which takes the historical data and learns from it. Okay, the way we just learned from the historic data, we figured out A, B, C, those coefficients. And once we have figured out those coefficients, we can do the prediction. Okay.
Okay, got it.
Okay, so structure do that for that traffic problem. Okay, traffic load prediction. Design your class so that you can just give it the data and it just predicts the value. Okay, and that's not hypothetical, by the way. It is used a lot. Okay, it is used a lot, and it is asked in really good companies interviews. When you go for top companies interview, probably in machine learning interview round, they will ask you this. Okay. And yeah, perfect. And I'll be committing this code. So this would be available to you. All right. Thank you so much. And I look forward to see you tomorrow.
Thank you, Sandeep.
Thanks, Sandeep.
Thanks, Sandeep.
Thank you, sir.
Thanks, Sandeep.
I'm just committing it. Yeah. Bye-bye. Have a good day.